Composites, glass ionomers, and Compomers. Key terms: direct placement aesthetic materials, tooth-colored materials that can be placed directly into the cavity preparation without being constructed outside of the mouth first. Composite resins, direct placement, tooth-colored materials composed of an organic resin matrix, inorganic filler particles, a coupling agent, and coloring pigments. Organic resin matrix, thick liquids made up of two or more types of organic molecules, polymers, that form a matrix around the filler particles. Inorganic filler particles, fine particles of quartz, silica, or glass that give strength and wear resistance to a material. Silane coupling agent, a chemical that helps to bind the filler particles to the organic matrix. Pigments, coloring agents that give composites their color. Monomers, high molecular weight molecules that act as a building block to link by covalent bonds to form larger complex molecules known as polymers. Polymerization, the joining of monomers end to end to form chains or networks of polymers, often causing a material to harden. Self-cured composites, composites that polymerize by a chemical reaction when two filled resin pastes are mixed together. Light-cured composites, single-paste composites that polymerize when a photosensitive chemical is activated by light in the blue wave range. Depth of cure, the depth to which light from a curing unit can penetrate and cure composite resin. Dual-cured composites, composites that contain components of light-activated and chemically activated materials. When the two parts are mixed together, it polymerizes by a chemical reaction that can be accelerated by blue light activation. Incremental placement, a technique for composites that places and cures small increments individually to reduce the overall polymerization shrinkage stress in the restoration and permit curing throughout the entire increment. Elastic modulus, a measure of the stiffness of a material. The higher the elastic modulus, the stiffer the material. Microfilled composites, an early generation of composites that contain large filler particles ranging from 10 to 100 microns. Microfilled composites, composites that contain very small filler particles averaging 0.04 microns in diameter. Hybrid composites, composites that contain both fine fill and microfill particles to obtain the strength of a macrofill and the polishability of a microfill. Microhybrids, hybrid composites that contain fillers that are smaller fine particles of 0.0421 and micro-sized fillers. Nanohybrids, microhybrids to which nano-sized fillers have been added. Universal composites, composites that have physical and mechanical properties such as strength and polishability that allow them to be used in both the anterior and posterior parts of the mouth. Nano composites, composites that contain all nano-sized fillers to enhance physical properties. Flowable composites, light-cured, low-viscosity composite resins. Bulk fill composites, composites with greater depth of cure that permit placement in large increments up to 4 millimeters thick instead of the standard 2 millimeters. Their use speeds up the filling process. Indirect placement aesthetic materials, tooth-colored materials that are used to construct restorations outside of the mouth in the dental laboratory or at chairside on replicas of the prepared teeth. They are later cemented to the teeth. Glass ionomer cements, self-cured, tooth-colored, fluoride-releasing restorative materials that bond to tooth structure without an additional bonding agent. Resin modified or hybrid glass ionomer, a glass ionomer to which resin has been added to improve its physical properties. Nano ionomers, glass ionomers that contain nano-sized filler particles to enhance their physical properties. Compomer, composite resin that has polyacid fluoride-releasing groups added. And bioactive dental materials, materials that interact with living tissue and are used to remineralize and repair dentin.